Hello students, so welcome to part 9 of the lecture series on previous year GATE questions on the topic of basic concepts in network theory. So this is question number 27 and this is a circuit given to us. Now as we can see, so let me copy the figure first of all. Now as we know that I1 is equal to 2 amperes, so this is 2 amperes. I4 is equals to -1, so I can say that 2 amperes is coming, and since I4 is -1, so I can say that 1 ampere is going in this branch. So by simple KCL I can say that the current in this branch will be 1 ampere and this is I2. So I2 is 1 ampere. Now it is given that I4 is -4, I5 is -4. So I can say that the current in this branch is 4 amperes. So 1 ampere in this branch, 4 ampere is going outside. So the current in this branch will be equal to 3 amperes by simple KCL. Okay. Now as at this node B, since the current in this branch is 2 amperes and in the another branch is 3 amperes, so the incoming current, that is I6, has to be 5 amperes. Okay, so this is by the simple KCL at the 3 nodes I am getting the results. Okay, so I can say that I6 is equals to 5 amperes. So in the question we have to answer which of the following statement is true. So we can say that I6 is equals to 5 amperes is the correct answer to the question. Okay, so very simple question, only I have to apply KCL at the 3 different nodes and I will get the answer. Okay, now another question, question number 28. So we have to find the value of current I. Okay, so let me draw the figure again. It is 5 volts, 5 ohms, 1 ampere current, and the total resistance in this path is 15 ohms. So the current here is capital I. Now let us say that this terminal or this node is grounded and the voltage at this node is VA. So let us apply the simple KCL at the node. So current in this branch will be VA minus 5 divided by 5. Current in this branch is VA divided by 15, and since these two currents are the outgoing currents and this is the incoming current, so where the -1 is equals to 0. So VA by 5 minus 1 plus VA by 15 is equal to 1. Okay, is equal to 2. Now let us take 15 as common. So we will get 4 VA is equal to 2. VA is equals to 15 into 2 divided by 4. Okay, and so we get the value of the VA voltage. Now I is equal to VA upon 15. Okay, so the answer is VA upon 15. So since we know the value of VA, so I is equals to VA upon 15, that is equals to 2 upon 4, that is 1 upon 2. So the answer to this question is 0.5. So the answer to this question is 0.5 amperes. Okay, now let's move on to the next question. Again, it's a question of star delta transformation. So here the resistances of star is given and we have to find the value of R1. So now as we know that the formula is R1 is equals to the resistances to which it is connected, 5 plus 3, the product of the resistances divided by the resistance opposite to it, that is 7.5. So it is 8 plus 3 divided by 1.5. So it is equal to 10. So we can say that the value of resistance is 10 ohms. Okay. So you can see that there are many questions related to star delta transformation. So it's better to learn the formula. So I have created a video how to learn the formula of star delta transformation. So you can watch that. It's available on the channel. Now let's move to question number 30. A very simple question. So the circuit represents voltage control voltage source, voltage control current source, current control current source, or current control voltage source. A very simple question. Since here it's a current source, okay, here it's a current source because it is representing the current source and it is depending on the current flowing in another branch. So it is simply a current dependent current source. Okay, very simple question. So now let's move to another question. Here it is given that value of resistance R is 25 plus I by 2. So we have to find the value of current. A very simple question. 300 volt is the battery and this is resistance R. So according to Ohm's law, current is equals to 300 divided by R. Okay. So let us put the value of R, that is 25 plus I by 2. So we can get that 300 is equals to 25I plus I square by 2. Now solving the equation, we can get that I square plus 50I minus 600 is equal to 0. That is I square plus 60I minus 10I minus 600 is equal to 0. I plus 60, I minus 10 is equal to 0. So I is equal to minus 60 and 10. Since current cannot be negative because current has to flow from the battery to the resistance, so the current value will be 10 amperes. Okay, so you get why the current cannot be negative, because current has to be positive because it has to flow from the battery to the resistance. Okay, now let's move to the another question. So here delta is given and here star is given. It is given that if all the elements of delta connection are scaled by factor k, the elements corresponding to star will be scaled by what factor? Okay, so let us assume that we have a delta connection where all the resistances are of value capital R. Okay, now the value of, for example, let us say this is RA, this is also RA because they all will be of same value. So RA will be equal to R plus R divided by 3R, that is 2 by 3R is equal to RA. Okay, now let us scale the resistances by factor k. Now the star will be, let us say again it is RB, there will be of same value. Now the value of RA will be equal to R into R divided by the resistances to which it is connected, divided by the value of sum of all the resistances of the pi circuit or the delta circuit. So that will be equal to R by 3. Now let us scale the resistances of the delta network So let us say the star has resistances value RB, RB and RB because they will be of the same value. So RB will be equal to R by K into R by K divided by 3 R by K. So this will come out to be R by 3 K is equal to RB. So we can say that they are scaled by the factor of K only. Okay, because earlier the value by R was R by 3 and now the value is R by 3K. So they are scaled by the factor of K. So B is the correct answer. Okay, so let us stop here, and few questions are left in this section. We will be solving it in the next part of the lecture series. So thank you guys. Keep sharing these lectures and subscribe to the channel.